Hey everyone, welcome back to the channel. We're your AI experts, and today we're going to be looking at something that you use pretty much every day without even thinking about it.
That's right.
Alternating current, or AC.
We're going to break down how it works, why it became the dominant form of electricity,
Right.
and its impact on our modern world.
To start, can you
Okay.
explain what makes AC so different from direct current?
Okay.
Or DC? I
Yeah.
mean, electricity is electricity, right?
Well, not quite. The key difference is in the way the electricity flows.
Okay.
With DC, the current flows in one direction,
Right.
like water flowing down a river.
Uh-huh.
But AC, as its name suggests,
Right.
constantly changes direction, a wave oscillating back and forth.
Interesting. So how does that wave-like motion make a difference? Does it affect how we use electricity?
It makes a huge difference.
Yeah.
That back and forth motion is what allows us to use transformers,
Okay.
which are devices that can change the voltage of the electricity.
Transformers.
Yeah.
Like those big metal boxes you see on power lines.
Exactly. With AC, we can use transformers to boost the voltage really high for efficient transmission over long distances,
Right.
then step it down to a safe level for use in our homes and businesses. That's why you don't see giant power plants right next to your house.
Ah, that makes sense. But how did we even get to this point? Wasn't everything DC at first?
You're right. Early electrical systems were primarily DC,
Yeah.
championed by Thomas Edison himself.
Interesting.
But transmitting DC over long distances was incredibly inefficient.
Yeah.
Imagine trying to send electricity from a power plant to a city miles away
Right.
using DC. A huge amount of energy would be lost as heat along the way.
So basically flickering lights and constant power outages. Not exactly ideal.
Precisely. That's where AC came in.
Okay.
Its ability to be transformed made it a much more practical solution for delivering electricity to the masses.
Right.
This led to what's known as the War of the Currents,
Okay.
a battle between AC and DC for supremacy in the electrical world.
Wait, a war? Like people were fighting over electricity.
Well, maybe not literally fighting,
Okay.
but it was a fierce rivalry. Edison, being heavily invested in DC,
Right.
tried to discredit AC, even resorting to some questionable tactics to make it seem dangerous.
Uh-huh.
He even publicly electrocuted animals with AC to scare people.
Wow, talk about a smear campaign.
Yeah.
But clearly it didn't work, did it?
No, because AC had a clear advantage, and a key invention really tipped the scales in its favor:
Okay.
the closed-core transformer.
Okay, this is where it gets really interesting. Tell me more about this game-changing transformer.
It was developed by 3 Hungarian engineers,
Okay.
Karoli Zipernowski,
Yeah.
Otto Blathy, and Mixaderi. Their design significantly improved transformer efficiency, making AC power systems even more practical and economical.
So these 3 engineers were essentially the unsung heroes of the AC revolution.
You could say that their work paved the way for the widespread adoption of AC, and we owe them a lot for the convenience and power we enjoy today.
Absolutely.
Yeah,
And once AC started taking off, did that lead to any other important innovations?
definitely. As AC systems spread, inventors and engineers began developing key components like the AC motor, which is essential for powering all sorts of machinery,
Right.
figures like Galileo Ferraris.
Okay.
And again, Nikola Tesla played significant roles in developing these technologies.
It seems Tesla really had his hand in a lot of the important developments surrounding AC.
He was undoubtedly a key figure, and all of these advancements led to some pretty impressive feats.
Yeah.
Like the electrification of entire cities, starting with Rome in the 1880s.
Wow.
Can you imagine? Entire cities illuminated for the first time thanks to AC power.
That's incredible. So in a relatively short period of time, AC went from being a controversial alternative to powering entire cities.
Yeah.
How did things move so quickly?
Well, several factors came together at the right time. First, that closed-core transformer we talked about made AC transmission incredibly efficient over long distances. Then the invention of the AC motor meant we could use AC to power all sorts of machines, not just lights. And finally, entrepreneurs like George Westinghouse saw the immense potential of AC and invested heavily in building AC power systems. It was a perfect storm of innovation engineering and business savvy.
So from flickering candles to brightly lit cities in just a few decades, that's a pretty remarkable transformation. But let's fast forward to today. How does AC impact us in the 21st century? I mean, we don't exactly see giant transformers in our living rooms.
That's true, but AC is still the invisible force behind our modern world. It powers practically everything from the obvious things like lights, appliances, and our heating and cooling systems.
To my very essential coffee maker every morning, I can't live without that.
Right, but AC's influence goes far beyond just powering our homes. Think about the information age we live in. AC plays a crucial role in transmitting data through telephone lines, cable TV networks, and even the internet.
Hold on. So the same principle that powers my coffee maker is also sending information around the world at lightning speed. That's mind-blowing.
It is pretty amazing when you think about it. AC's versatility stems from its ability to operate at a wide range of frequencies. Lower frequencies are perfect for things like powering motors and appliances, while higher frequencies are used for things like communication signals. It's like having a toolbox full of different AC frequencies, each perfectly suited for a specific task.
Okay, that makes sense. But even with all its advantages, are there any limitations to AC technology?
You're right, even AC has its drawbacks. One major challenge is energy loss at very high frequencies. You think about it like trying to yell a message across a noisy, crowded room. Some of the sound gets lost in all the commotion. Similarly, as AC frequencies increase, a portion of the energy radiates away instead of being transmitted efficiently.
So how do engineers overcome that problem? Do they have some secret high-tech solution?
Well, it's not exactly secret, but it is pretty ingenious. Engineers use specialized components like coaxial cables and waveguides to contain those high-frequency AC signals and minimize energy loss.
Coaxial cables. Those sound familiar. Aren't those the cables we use for our TVs and internet connections?
Exactly. Think of them as carefully designed pipes that guide the high-frequency AC, preventing it from radiating away and ensuring that your cat videos arrive on your screen in pristine condition.
So it's not magic, but it's definitely impressive engineering. Are there any other downsides to using AC?
There are a few other things to consider. AC systems can be susceptible to interference from external sources like lightning strikes or electromagnetic disturbances. That's why you might see your lights flicker during a thunderstorm.
That makes sense. It's like a sudden surge of energy disrupting the flow.
Precisely. And because AC involves constantly changing voltage and current, it can also lead to wear and tear on components over time, especially moving parts like motors.
So while AC may not be perfect, it sounds like it's still the best option we have for powering our modern world.
That's a fair assessment. And it's important to remember that AC systems are incredibly complex. From generating electricity at power plants to distributing it to our homes and businesses, it's a remarkable feat of engineering and coordination.
And that complexity is something we often take for granted. We just flip a switch and expect the lights to turn on without even thinking about the intricate network of technology that makes it possible.
Yeah, it really is incredible when you break it down like that.
It is.
From powering our homes to enabling global communication, AC has revolutionized our world.
Absolutely.
But before we wrap up,
Yeah.
I'm curious about something. What are some of the things researchers are exploring when it comes to the future of AC?
Well, that's a great question. There's always room for improvement, even with a technology as established as AC.
Right.
One area of active research involves developing more efficient and robust AC grids, especially as we transition to renewable energy sources like solar and wind power.
Yeah.
These sources can be intermittent, meaning they don't generate electricity constantly.
Right. So the grid needs to be smarter and more flexible to handle these fluctuations.
So it's about finding ways to make the grid more adaptable and reliable, especially as we move toward cleaner energy sources.
Exactly. Another area of exploration is high voltage direct current,
Okay.
or HVDC transmission. While AC has dominated for over a century,
Right.
HVDC is becoming increasingly attractive for long-distance power transmission,
Interesting.
especially for connecting renewable energy sources that are located far from population centers.
So is DC making a comeback? Is the war of the currents reigniting after all these years?
It's not so much a war as it is a recognition that both AC and DC have their strengths and weaknesses.
Okay.
For local distribution and general use, AC remains highly effective. But for transmitting vast amounts of power over very long distances with minimal losses,
Yeah.
HVDC is proving to be a strong contender.
So the future of electricity might involve a combination of both AC and DC, each playing to its strengths.
That's a very likely scenario. And it underscores the importance of ongoing research and innovation in the field of electrical engineering.
Well, it sounds like there's still a lot to discover and improve when it comes to electricity. Who knew a topic like alternating current could be so fascinating?
It is. It's all about understanding the fundamental principles
Right.
and then exploring how they can be applied in new and creative ways to meet the evolving needs of our world.
Well said. And of course, if you enjoyed this discussion, make sure to hit that subscribe button
Yes?
and leave us a comment below. Let us know what other topics you'd like us to explore in future videos.
Yeah.
We're always excited to dive into new areas and share our knowledge with you.
We'll see you in the next video.